Okay, show by counterexample that the statement if c plus 1 all squared equals to d plus 1 all squared, then c has got to equal d. And they say show that is false. Okay, so essentially c plus 1 squared equals d plus 1 squared can happen even if c is not equal to d. And that's sort of like a little bit strange, isn't it, I guess, looking at this. However, if we start looking at some numbers, right, and for instance, suppose these were equal, and suppose the result of this came out to be 4. Okay, so c plus 1 all squared was equal to 4, and so was d plus 1 all squared. So we've got that equals to 4, and d plus 1 all squared equals to 4. So I can work out then what c and d is, and you'd automatically expect c to equal d, yeah? However, we are squaring, aren't we? And, if I was to solve this to work out c here, okay, you take the square over the other side, and you just need to appreciate, if you take the square over the other side, there's two possible answers, aren't there? So you could have plus or minus the square root of 4, okay, and the same here then, d plus 1, okay, take the square over, plus or minus square root of 4, okay. Now, if I took both positive results, then I would get c and d to be the same, okay. However, if I took one of them to be positive and the other one to be negative, you'll get c and d to be different, okay. So c plus 1, if I take the positive one here, okay, so the positive root 4, okay, and here I take the negative root 4. Of course, we know root 4 is just 2, so c then would equal to 1, and then in this case then we'd have minus 2, so d would equal to minus 3. So we've actually found a condition now whereby c plus 1 all squared is equal to d plus 1 all squared, but c is actually not equal to d. Okay, so here's our counterexample, and we can check it. Okay, if I set c to equal 1, put it in there. Okay, so c equals 1, okay, implies c plus 1 all squared will be 1 plus 1 all squared, which is 4. And then if I set d to equal minus 3, that implies then d is minus 3 plus 1 all squared. So minus 3 plus 1 is minus 2, okay. And of course minus 2 all squared will be 4, okay. So we've got a situation whereby c plus 1 all squared is equal to d plus 1 all squared, but c is not equal to d.